Hi everyone, welcome to Eagles EduConcepts, a platform that provides you with quality education, science, and mathematics, starting from secondary level all the way up to A levels. If you're visiting this channel for the first time, don't forget to click on the subscribe button so that you can have access to more content. In this lesson, we're going to deal with AS level organic chemistry. The topic that we're looking at is nomenclature of organic compounds. So let's first of all just talk about the naming of organic compounds. So many organic compounds have got common names that are derived from Latin or Greek words that indicate one of their natural sources. So depending on where it comes from, they can come up with a name there, and that one is what we call the common name. All right, however, most organic compounds can also be named by following some laid down rules, and these rules are called systematic or substitutive names. So the names that you come up by following a set of laid down rules is what we're going to call the systematic names or the substitutive names. All right, so the body that sets up these rules is called the UPAC. Now, the letters, rather the acronym UPAC simply stands for International Union of Pure and Applied Chemistry. All right, let's dive right straight into the nomenclature. So nomenclature is a standardized way of naming organic compounds. Nomenclature basically takes into account two things. The first one is what we call a prefix. Now, a prefix, it simply shows the number of carbon atoms in an organic compound. So usually, if you remember your English very well, a prefix is just referring to the first few letters of a main word. Okay, so I think in a word, we've got a prefix, main root, and a suffix. So prefix is just the first few letters of a word. So this one, it's usually at the beginning of the name. Then it also puts into consideration what we call a suffix. So the suffix, this one shows the organic family of the organic compound. So it's usually at the end of the name. I would like for you to consider it more like a surname. So a suffix, just consider it as a surname and things will be simplified for you. Okay. Let's look at the prefixes that are found in organic chemistry. So we'll just look at the first 10 prefixes that are found in organic chemistry. And when you are studying organic chemistry, I think it needs your attention. So it's not something that you just look at and believe you've understood. It's something that actually you have to be looking at from time to time, practice, then you'll be okay with it. So the first 10 prefixes in organic chemistry, and this forms the foundation upon which the other organic compounds are named. These are the ones that are shown here. So we've got the meth, eth, prop, but, pent, hex, hept, oct, non, and dec. So in the order in which they are arranged, meth, it simply means one carbon atom. Eth, it simply means two carbon atoms, and so on and so forth. So the moment you see these letters anywhere, meth, just know that there is one carbon atom there. It doesn't matter what letters follow after, but as long as at the beginning there is meth, then you know that it's one carbon atom. If it's eth, then you know that it's two carbon atoms. If it's prop, then it's three carbon atoms. If it's hex, then you know it's six carbon atoms, and so on and so forth. Now, just a quick example of a few of the suffixes that are found in organic chemistry. We are going to have ANE. This is a suffix for a family called Alkanes. We've got ENE. This is a suffix for a family called Alkenes. And YNE, this is a suffix, rather a surname for a family called Alkanes. We also have the OL, and let's consider the OL here. So the OL, this is the suffix for a family called alcohols. And lastly, we've got the OIC. So here we're just going to consider OIC. This one is the suffix for what we call the carboxylic acids. All right, so let's quickly look at an example on how we can combine. Now, coming up with a name of an organic compound is basically about, generally, it's about just joining the prefix and the suffix together, and you come up with a name. Other specific details, like considering the number, the position of the substituents, and so on and so forth, will come in later on. But in its simplest form, when you are naming organic compounds, simply get the prefix and the suffix, put them together, and you're okay, good to go. All right, so nomenclature of alkanes. Now, alkanes are the simplest of all the homologous series in organic chemistry, and as such, they form the basis for naming other organic compounds. Okay, straight chain alkanes. Let's look at the number of carbons there. 1, 2, 3, 4, 5. So if we are to apply in the prefixes, you know that this one is going to be this one is going to be meth, this one is going to be eth, this one is going to be prop, this one is going to be but, this one is going to be hept. You should bear that in mind. Now, these molecular formulas, you know by now that molecular formulas, they come from the general formula. Now, if you remember very well, from the previous video, we looked at the general formula for this family, and we discovered that it was as CnH2n plus 2. Okay, so it was plus 2. This was the general formula. Now, here, since it's number 1, so we are just going to put a 1 here and the 1 here. So this one will be C1H, then 2 times 1 is 2. So 2 plus 2, that is 4. So C1, then H4. So 1, we usually ignore it. So this is where the CH4 is coming from. You can pause the video and just practice also with 2, 3, 4, and 5 and see how you're going to come up with these molecular formulas. Because if you're doing for 2, then you are going to put a 2 there, then you're also going to put a 2 there. So this becomes C2, then 2 times 2, that is 4, 4 plus 2, that is 6. That is where this one is coming from. Pause and practice. All right, so number of carbons, we've got the molecular formula there. Then we also have the prefix. Remember, prefix meth means 1, eth means 2, prop means 3, but means 4, pent means 5. Okay, so then also because we are looking at the alkanes, so generally we are saying the suffix for all alkanes, it doesn't matter the number of carbons, is simply ANE. So that is our ANE. Then finally now, if you want to name these alkanes here, you're just going to get prefix plus suffix. So meth plus ANE gives you methane. Eth plus ANE gives you ethane. Prop, propane. But, butane. Pent, pentane, as shown here. So it is as simple as that. Let's look at some substituted alkanes, meaning other groups have come in. So for substituted alkanes, if there are any side chains or functional groups present, then these groups are indicated by numbering the carbon atoms in the longest chain, starting at the end. All right, let's try to put more sense into this thing. So we are saying the hydrocarbon side chain is shown in brackets in the structure formula. For example, this one, and I want you to bear in mind that most of the side chains that you're going to deal with, we're going to deal with the CH3 or the CH2CH3. So we have got the CH3, which is known as the methyl group, and we've got the CH2CH3, which is known as the ethyl group. So the main chains, side chains that we'll be dealing with is number 1, this group here, which is called the methyl, okay? Then we also have the one which starts with CH2, then CH3, which will be called the ethyl group. Now, the side chain is named by adding YL to the normal alkane stem. So this type of group is called an alkyl group. So when you add YL to the main alkane stem, for example, if you had methane, you remove ANE and put YL, then it becomes a methyl. Okay, so that one will be called an alkyl group. So we've got a methyl, ethyl, and propyl, butyl, and so on and so forth. Let's look at the first example here, which says name the organic molecule below. So like we said, this one is branched. As you can see, we've got these straight ones here. Then we've got this one, which is on its own, which is branched. So the first thing that you do is you have to identify the longest continuous chain of carbons. So you can see we have a carbon, we have a carbon, we have a carbon, a carbon, a carbon. So this is the longest. So that one is going to give us what we call the parent name. So the parent name, just count. Remember, if you count the number, you add the prefix and then you add the suffix, then it gives you the name. So here we have 1, 2, 3, 4, 5, 6. So we are counting the carbon atoms. So 6. 6 is hex. Okay. So when you add ANE as the family name, then it's going to be hexane. Okay. So this is hexane. Okay. Then now, how do you know is the correct numbering? I always advise people number from both ends. So the first thing we're going to do, we are going to number from here. So numbering from here, these are the blue or rather purple numbers that are here. So 1, 2, 3, 4, 5, 6. Then you also number from the other end. So starting from the other end, it will be 1, 2, 3, 4, 5, 6, as indicated by the green numbering here. Okay, then which one is the correct numbering? So you have to number such that at the branch, okay, so I'll emphasize at the branch there, at the branch, okay, at the branch, it has the lower number. You pick the one which is lower. So for example, if you start from here, the branch will be on number 3. But if you start from my right here, the branch will be on number 4. So the correct numbering is starting from the left because it gives the branch to be number 3. So this is the correct. So please number starting from both ends and then look at which one has got a lower number. So what we want is to have the lowest possible numbers. So if you start from the left, it will be 3. If you start from the right, it will be 4. So start from the left so that you can get a 3. So you keep that 3, okay? Then you've also kept the parent name here. So the parent name is derived from the longest chain. So here we figured out that this one was what? Was hexane. Okay, so hexane. So you keep the name hexane, okay? Then you also keep the branch, the number of the branch where it is branching from. Then also you take note what name is given to the branch. Now remember, this is CH3. Now CH3, this one, like we said, these are the ones we'll be dealing with. So this one will be known as the methyl. So this is the methyl group where you just, to the prefix here, the prefix is like this. So you just need to add YL. So this one becomes methyl. Then now, since we have figured out this thing, so the first thing, like I said, identify the parent chain, which will provide the parent name. Then identify the lowest number possible by numbering on both sides. And then you choose which one is lower. And then you look at the name of the side chain itself. So when numbering now, you're going to start with the position where the chain is, position, the chain, then the parent name. So that is the order. So position where the chain is branching from, the name of the chain, and then finally the parent chain. So this one, the name here, that's why it is becoming 3-methylhexane. So the name will just be 3-methylhexane. All right, you can pause the video, read through the rules. The longest chain of carbon atoms is 6. That's why we got the hexane. Okay, then the name of the chain is methyl. Then the position where it is branching from, it should be the lower. That's why you have to number from both ends so that you can easily compare. Okay, we also have a situation where we have polysubstituted alkanes. Now, the previous example, it was substituted quite all right, but it was just one. But here we have a situation where it is polysubstituted. Now, polysubstituted meaning it has got more than one branch, okay? One side, more than one side chain. So if there are more than one side chain of the same, for example, if you've got a lot of methyls, maybe 2, 3, then we're going to use the numbers di for 2, tri for 3, tetra for 4, and so on and so on and so forth. Okay. Now, there is a situation where they are polysubstituted quite all right, but they are not the same. So if such happens, then you're just going to follow the alphabetical order. All right. Also remember that the adjacent numbers have a comma between them. The numbers are separated from words by a hyphen. A hyphen, simply what you saw like a dash. Okay. Then if there is more than one type of alkyl side chains, they are listed in alphabetical order. So those are the simple rules that you need to follow. Once you follow that, then you'll be able to come up with the systematic name of whatever compound that you'll be given. Let's look at the example. Okay. All right, so here we can identify the first thing. Let's identify the longest chain. Obviously, it is this one here, which is in red. So you count here, these are, then you number starting from both sides. Like I said, you number starting from both sides. So you number 1, 2, 3 up to 6. So this is also a hexane. Then you can also number from here, 1, okay, 2, number, let's just number 3. Then this one here will be 4. This one here is going to be 5. And then we're going to have 6. So you number from both sides. Then you have to choose. Now, if you start from my right here, if you start from the right, the first chain is going to be 3. It's going to be on 3. Then the other one is going to be on 4. Then if you start from the left, again, we're going to have 3 and 4. So in this situation, it doesn't matter where you start counting from because it is still giving you the same numbers 3 and 4 because there are 2 of them. Now, if you check here, so we have said this is the hexane here. So this is the hexane. Okay, I'll just write H for hexane. Okay, and also here I've checked hexane because it has got single bonds and not double bonds. So we have to bear that in mind as well. All right, so hexane. Then the name of the chains here. So this is a methyl group, but we have this as the first methyl group here. Then we also have another methyl group. Then also we have another methyl group there. So we have 3 of them. Okay, we have 3 of them. Okay, so since we have the 3 of them, we can combine now. These since there are 3 of them, we can say this is just 3, 4. So this is 3, 4, then trimethyl. Okay, trimethyl. Let's look at this. Okay, so this is 3, 3. Now here, this is 3. Okay, so when you start from here, so here, like I said, because here there are 2, 1, 2. So the correct numbering actually here comes to be these ones in green because on 3 here, there are 2. But if you start from here, on 3, there is just 1. So it's better you start from here where there is 2 on 3. So this is 3, 3, meaning that on position 3, there are 2 of them. So 3, 3, 4, trimethyl hexane. I hope this is clear. 3, 3, trimethyl hexane. Now, like I said, let me repeat this one. You number on both ends, then you discover that at 3, 4, they were branching. So initially we said it can be the same, but on the second thought, when you check, since on this position here, there are 2 of them, so it's better we prioritize it so that it becomes the third one. So the correct numbering starts from my left here. Okay, so this becomes 3, 3 because on 3, there are 2 of them. So 3, 3, and then here there is 1. So 3, 3, 4, trimethyl. So tri meaning 3. And the parent here, we said it's hexane. So just join them together and you are done with the name. So remember, if they are polysubstituted, the commas, they separate the numbers, but these numbers and the word is connected by a hyphen. Okay, let's look at this other example. We can do the numbering here. You can number, by now you can number, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now, if you count, this is 1, 2, 3, 4, 5, 6, 7. Also here, this is 1, 2, 3, 4, 5, 6. So the longest continuous chain here is actually the one which has got what? The one which has got the 6. Okay, longest continuous chain, not just any chain, but longest continuous chain. So it's got 6. So you can also number from here 1, 2. This is 3, 4, 5 there, and this is 6. Okay, So you number both sides. Then let's look at the chain. So we've got a chain here and a chain here. So now when we start numbering from here, we are going to have our first chain on 2. So the first chain will be on 2, then the second one will be on 4. But if we start numbering from here, the right-hand side, the first chain is going to be on 3, then the second one on 5. So 3 and 5 are definitely higher than 2 and 4. So the correct numbering is to start from here. So as a result, we know that this methyl group is on 2. So this is 2, comma. So this one will be 2, comma. Then the second one is on 4. So what you're going to do is, on 2, we have a methyl. So you're going to write 2 methyl, okay? 2 methyl, then 4 ether, 4. So this one, if you check it properly, this is 1, 2, 3. So this is a propyl, okay? So 1, 2, 3, from prop, you just add YL, it becomes propyl. Okay, let's look at the full name. So remember the rules, identify the longest continuous chain, it gives the parent. So the parent here, we figured out it was actually a hexane. So this is hexane. Then also we've identified the correct numbering and also the names of the side chains. Then we put them together, we are going to come up with this one. So 2 methyl, then 4 propyl. So it's telling us that on position 2, we have a methyl. On position 4, we've got a propyl. So just like driving a vehicle, if you are a driver, you can take it forward, you can also take it backwards, you can reverse. So from the name, you can draw the structure. From the structure, you can come up with the name. All right. Now, like I said, alkanes, they just form the basis of naming, okay? But how about if we bring in the other organic compounds into play? Okay, so the same rules are just going to be modified, with respect to the functional groups that they have. So most of the families of organic compounds, their names are primarily derived from alkanes. Other things such as functional groups or suffixes of different homologous series are put into consideration when deducing the names. So the only thing that is going to be different is the suffix, but the prefixes will be the same like we gave in the beginning of this lesson. So the suffixes are going to be different because just like here on Earth, different families have got different surnames. We've got the Bandas, we've got the Mwanzas, and all those other funny names. Same applies to organic chemistry. Okay, so names derived in such a way, like we said, they are known as systematic what? Names. Okay, so just a recap on the various functional groups that we have and those that are going to change the naming. We've got the alkanes. By now, people should know that alkanes is just a carbon-carbon double bond. Then we've got the alkenes, which is the carbon, this alkanes is the carbon-carbon single bond. Then the alkenes is the carbon-carbon double bond. Then we've got the alkynes, which is the carbon-carbon triple bond. We've got the benzene ring, which can also be called a phenyl group. We've got the alkyl halides, which is the bromide, fluoride, chloride, iodide. We've got the thiol group, we've got the alcohol, we've got the aldehyde, we've got the ketone, we've got the ester there, we've got the carboxylic acid, and we've got the amide. So all these are supposed to be considered when you are naming these other organic compounds. Let's quickly look at an example in conclusion. Examples, just 6 of them. So for the first one, what you have to do primarily, so they've said we should name these molecules here. Let's see how we can name them. Okay, so number 1, the first thing that you have to do is identify the longest continuous chain, which has been done here in the red line. So this is 1, 2, 3, 4, 5, 6. Remember what we said when we are introducing in the other video about the skeletal formulas. So here there's a carbon, at the bending here there's a carbon, there's a carbon, there's a carbon, a carbon, and a carbon. So that's why we are putting these numbers 1, 2, 3, 4, 5, 6. Then you also look at the functional group. So here we have this functional group here. So this, since there's a carbon here and a carbon, this functional group is giving us this one here. Carbon, what we are calling a carbon-carbon double bond. So carbon-carbon double bond. Okay, so this one is an alkene. So you know that when you count this one, 1, 2, 3, 4, 5, 6. So this one, the name will be like hexene, hexene with E-N-E at the end. E-N-E at the end. So hexene. So the parent name here is hexene. However, you have to mention also these, the branches. Where are they branching from? So here, when numbering for alkenes, you don't just number both sides, but you also have to make sure that the double bond has got the lowest number possible. So for example, if we started from here, it would be 1, 2, 3, 4 will be here, this one will be 5, and this one will be 6. So now the double bond is the one that is supposed to have the lowest number possible. It's not just about the branches. Also remember, at the far end here is the C, and I remember there we said a carbon needs to have 4, so it's going to have like that and like that. So these together will form CH3. So this is H, this is also H, and this is also what? H. Okay, so this is CH3, CH3. Also, this one is CH3. So already we have 3 branches. We have 1, 2, 3. Then this one here, this is 2. So it's on position 2. So the correct numbering here is to start from the left because the double bond will be on 2. But if we started from the right, the double bond is going to be on 4. So when it comes to alkenes, you follow the double bond. The double bond is the one that is supposed to have the lowest position. All right, so having that said, following the same rules, we are going to say here what we have is 2, comma, so here 2, comma, 5, comma, 5 trimethyl, then dash 2 hexene. Okay, so the name will be like this. So 2 on 2 here, there's a methyl. Then on 5, there are 2 methyl. There's 2 methyls, this one and this one. So this is why it's like 2, 5, 5. Then dash trimethyl. Then this 2 is trying to tell us that the double bond is on position 2. We originally like to say hexene, but where is the double bond? The double bond is on position 2. That's why we are putting this one as 2. It is just simply showing where the double bond is. Okay, let's look at our second example here. So the second example also, we are going to identify our longest chain. So if now here, we remember when numbering, we have to start from where the double bond is. So if we start from here, 1, 2, 3, this one will become position what? Will become position 4. So look at the double bond will be on position 4. So again, if we start from here to 1, 2, 3, 4, again it will be on position 4. So we have to start from where the double bond is. That will be our position 1. So 1, 2, 3, 4, 5. So as a result, our longest chain then becomes what? Our 5. So this one will be heptene. Okay, with E-N-E, heptene, heptene. So this is heptene. Now, is there any other branch? No. So here, if we start from here, then the whole lot of this one here is going to be a branch. So this is CH2, CH2, CH3. So that is a propyl as well. So as a result, we are going to have this. So here on 1, 2, this group here I've just counted. This is a carbon here, this is a carbon, and this is a carbon. So since there are 3, from prop, you put YL, it becomes propyl. So, and it is attached on carbon 2. So that's why we're saying 2 propyl. Then the double bond is on position 1. That's why we are putting 1 pentene. All right. Example number 3. Here also, you start from where, now here, you first identify, the functional group also. So the functional group here, it is telling us this is a CO here, okay? So this is a CO. So meaning on this carbon here, if you have a carbon, a double bond, and something else here, like oxygen or any other thing, then this one is called a carbonyl carbon. So always when you're numbering, you start from a carbonyl what? Carbon. So carbonyl carbon, this is 1, 2, 3. So 3, that is prop, okay? That is prop, okay? Now, because of this functional group here, it is an aldehyde, okay? Aldehyde. So this one is going to just be propan, okay? Propan, aldehyde. So aldehyde is just CHO. So if we want to simplify, the functional group is C H. So this is how you know an aldehyde is CH, then O. Where is the O? The O is here, the C is here. Then here, if you extend this one, we're going to have an H. Remember, in the other video in introducing, we said a carbon needs to have 4. So there's a carbon here, then 1, 2, 3, and 4. So this is where the H is coming from. So CHO, an aldehyde. So if it's an aldehyde or any other higher functional group, you have to consider starting to count from the carbonyl carbon. Okay, so the carbonyl carbon is the carbon that is double bonded to another atom. Carbonyl carbon is a carbon that is double bonded to another atom. All right, this other one here, also here, as you can see, by the functional group here, we know that it's an aldehyde. So because it's an aldehyde, we're going to start counting from the carbonyl carbon. So the carbonyl carbon here, which is number 1, 2, 3, 4. So on 3 here, we've got a methyl group, okay? A methyl group. So this one, we're going to just simply say 3. This is 3 methyl. So 3 3. So first of all, we say 1, 2, 3, 4. So that is butanol. So 3 methyl butanol. 3 methyl butanol. Okay. So 3 methyl butanol. So the parent name here is butanol with an AL. Butanol with an AL, because an aldehyde has got AL at the end. Aldehyde has got AL at the end. Okay, the 5th example. Here, as you can see, the functional group here, if you check it through, we have what we call the COO, okay? The COOH. So COOH, this one is a carboxylic acid. You should be able to recognize this one. So COO, like I said, if you have a carbon double bonded to another atom, then that carbon becomes a carbonyl carbon. So even when numbering, that is where you start from. So this one would be 1, 2, 3, 4. Okay. So now, because 4, it's but. From the prefixes, 4 is but. So because, and all carboxylic acids, they end in oic. So OIC acid. So but. So from a butane, you just add oic. So this one will become butanoic acid. Butanoic acid. Okay, so butanoic acid.